We're going to talk about problems involving projectile motion, such as throwing a ball, kicking a ball, launching something off of a rooftop, anything where you are using velocity and throwing something at an angle. We're going to use parametric functions to represent the situation. If you would, copy down the notes off of this page, so pause the video. Be sure that you write the equations and what the variables stand for. I do want to point out that the g variable, which stands for acceleration due to gravity, can only be two different numbers, and it depends on the unit that you are working with. If you are working with meters, then you will use 9.8. If your units are in feet, then you will need to use the 32 for the g variable. So you only have two choices for g, either 9.8 or 32, depending on whether it's in meters or feet. Okay, so here is the situation we're going to look at. Aaron hits a golf ball off the tee with an initial velocity of 150 feet per second. Pay attention to the feet at an angle of 30 degrees. And the first thing we want to do is write the equations that will model the path of the ball. So our x equation, again, was our initial velocity times the cosine of theta times t. So we're going to substitute in for the initial velocity and the theta. Initial velocity is 150 feet per second. Our angle is 30 degrees. And we're going to multiply those numbers together, so use your calculator to find 150 times cosine of 30. And when you do that, you should come out with 129.9038 times t. That's one equation, that's your x. And remember, your x represents your horizontal distance. Okay, now we also need a y equation. And y, again, stands for the vertical distance. And here is the equation that we're starting with. And we're going to substitute in numbers. Now keep in mind also, t is time. That is a variable in the equation. We're not plugging in for that when we're setting up the equations. Okay, so I've got my x equation. For my y, I have negative 1/2. And remember, we said g could only be 32 or 9.8. And in this case, it's going to be 32 because in the problem, I'm working with feet. So if you're using feet, you have to use 32. Okay, then we're going to put in for our v sub 0, again, is 150 for our velocity. The angle is 30 degrees times t. And then my h, my initial height, if I am hitting a golf ball off the tee, the ball is on the ground. So its initial height is 0 because it's on the ground. So let's simplify that and clean it up a little bit. Negative 1/2 times 32 is 16t squared, negative. 150 times the sine of 30 is 75t. And then I don't have to put the plus 0. If I had a number there, I would write it in. So here are my parametric equations to represent this situation. We're going to use those equations to answer the rest of the questions. Number 2, how long is the ball in the air? How long is asking me to find time. But I've got to decide, do I need my x equation or my y equation? And if it's talking about the ball being in the air, we are talking about height. And height would be y. So I'm going to use the y equals negative 16t squared plus 75t. Okay, now if the ball is not in the air, then it would be on the ground. And the height when the ball is on the ground is 0. So I'm going to let my y be 0 to find out when the ball is no longer in the air. So when it comes back down to the ground, that will tell me how long it's been. So negative 16t squared plus 75t equals 0. And there are several ways you can solve for t, but since it has a t squared, you either need to use quadratic formula or factoring. Since we've been using quadratic in class, we're going to do that to practice. If you know how to factor, you can also use factoring. Okay, so our A value would be -16. Our B is 75. And our C is 0. Our quadratic formula, opposite of B, plus or minus, B squared minus 4AC all over 2A. So let's substitute our numbers in. So we'll have -75 plus or minus the square root of 75 squared minus 4 times -16 times 0 all over 2 times -16. Okay, we start in the square root. 4 times 16 times 0 is just going to be 0. And since we've got the square root of 75 squared, that is going to end up being 75. So now I've got -75 plus or minus 75 over -32. So I'm going to add -75 plus 75 would be 0 over -32, or 0. And for my second answer, -75 minus 75 would be -150 over -32. And when you divide that, you come out with 4.6875 seconds. Okay, so if the ball started on the ground at 0 and came back down to the ground at 4.6875, then the total length of time it was in the air is the 4.6875 seconds. Okay, to find the distance the ball actually traveled, distance is referring to the x. So if I want the x, I'm going to have to know what the value of t is. Well, the ball was in the air for 4.6875 seconds, so I'm going to substitute that for the t value to figure out what my x value would be. Okay, and when you multiply those numbers together, you come out with 608.924 feet. So you have to use your answer for number 2 to figure out number 3. Okay, number 4 is asking when the ball is at its maximum height. Okay, and height again tells me I'm going to do something with my y equation. Okay, and when tells me I'm looking for t. If you look at the y equation, 16t squared plus 75t, that is a parabola if I were just graphing the y. And since it's a -16t squared, it would be a parabola that is upside down. Now in the last problem, we found out that the ball was on the ground at time 0 and at 4.6875. The maximum height on the parabola has to happen halfway between because a parabola is symmetric. So my maximum height is going to happen at the midpoint of those two numbers. So all I have to do to figure out when it hits its maximum is divide this number by 2. Okay? And when I do that, I'm going to come out with 2.34375 seconds. Now, if our ball had not started on the ground, then we would need the vertex formula for a parabola to figure out when. But because our ball started on the ground at 0, then we just need the midpoint of 0 and 4.6875. Okay, now number 5 says to determine the maximum height. So I'm looking for my y, and we just said that the maximum height occurs when t is 2.34375. So I'm going to substitute that number in. And then we're just going to use our calculator to work out and see what our answer comes out to. So we plug in the value for t that we got in number 4. And we simplify. And when you put that in your calculator, you should come out with 87.891 feet. That is the maximum height. Okay, again, anytime you're working with horizontals, you're looking at the x, vertical, you're looking at the y's. Okay, so number 6, after how many seconds, that means I'm looking for t, is the golf ball 230 feet from the tee horizontally? Horizontally means I need the x equation. Okay, so I'm going to start with the x equation. And if I'm looking for t, that means I need to substitute in for x. And my x value is the 230 feet. That's the horizontal distance that they gave me. So to solve for t, all we have to do is divide by the 129.9038. Okay, and our t value would be approximately 1.771 seconds. Okay. Know what your variables mean, and keep in mind that your x equation is for horizontal distances, your y equation is for vertical distances.